My name is Cassandra Gaston, and I'm at the University of Miami, and I'll be providing an overview of the Barbados Atmospheric Chemistry Observatory, or BACO. So this Google Earth image really captures our measurement capabilities quite well. So these are three sampling sites that are currently operated by the University of Miami. So we have a measurement facility in Cayenne, French Guiana, which can capture the winter and springtime transport of African dust to South America and the Amazon basin. And then we also have measurement sites in Barbados and Miami that can capture the summertime transport of African dust. I'm going to focus on the capabilities at the BACO facility because it's provided the longest measurement record in modern history for atmospheric aerosols. What I'm also showing in this Google Earth image is the distance between the African continent and these three sites. This gives you an appreciation for just the amount of time it takes to transport dust as well as other aerosols from the African continent to the Caribbean as well as to the Americas. And I'm also highlighting the latitudinal spread of our three measurement sites. So Cayenne is at about 4 degrees north, while Miami is at about 26 degrees north. So this is just showing just the sheer impact of African dust in the Caribbean as well as in the Americas. And what I'm showing here in this slide is 47 years of measurements that have been conducted in Barbados since the 1960s. So this is monthly means that are taken from daily filter records. So what you can see from this plot is that we get strong seasonality. So dust transport peaks in the summertime at this site. And then what I've also highlighted with these red arrows are years when we get either abnormally low or abnormally high levels of African dust. And we found that this is related to variations in climate, such as El Nino, La Nina years, as well as variations in African climate, which is really well summarized by this figure from Prospero and Lamb. What this is showing is Sahel precipitation anomalies with drier years being shown as positive values. And what you can see is that there's a correlation between drier years and increased dust emissions. And what this suggests is that dust transport and African climate are tied to each other. So changes in precipitation, wind patterns, as well as other factors in African climate could have an impact on future emissions of dust transport. And this is something that our site is really well primed to provide insight in because it is such a long record. So what I'm showing here in this slide is a couple of images of what the site looks like. So the site is located on Ragged Point, which is the easternmost part of the island. What I'm showing on the top right is the original facility at Ragged Point, and in the background is what the facility looks like today. We have an aluminum tower where we conduct high volume aerosol sampling. We have a local technician that climbs the tower daily, changes the filter in the 2 shipping containers, which are shown at the base of the tower. And then these filters are shipped to Miami for chemical processing. What I'm also showing is the A-gauge facility, which is run by the University of Bristol. So current measurement capabilities at BACO, we have 2 main modes of operation. We do long-term monitoring, which is mainly conducted by our technicians. And then we do focused field studies, which is mainly conducted by graduate students in my lab, as well as other university collaborators. So our main focus is on aerosols and their connection to climate and air quality. So we make long-term measurements of dust mass concentrations as well as soluble ions. So soluble ions can provide insight into changes, for instance, in nitrate and sulfate, which are important for looking at historical changes in air quality policies. We also have a CMEL instrument, which looks at aerosol optical depth. And then we also have a partnership with the Max Planck Institute, and they're conducting long-term real-time measurements of particle size using an SMPS and EMD. And then they're also looking at cloud nucleating capabilities using a CCN counter. For field measurements, my group recently participated in the International Eureka campaign, and we looked at deposition of nutrients, single particle measurements, including microscopy. We've become really interested in the transport of smoke from Africa to the site. And then we've also had recent collaborations that have looked at ice nucleation as well as wet and dry deposition. The University of Bristol's A-Gauge facility is looking at climatically relevant gases such as carbon dioxide, ozone, and non-methane hydrocarbons. So our current and future research questions and needs, our long-term measurements are really key for looking at this interplay between climate, aerosols, and gases, and how climate can affect their emissions, as well as how emissions of aerosols and gases affect climate, weather, and health. Our site is really the linchpin for understanding dust transport to the Americas and the Caribbean, and has been instrumental in ad hoc collaborative efforts through activities such as the Caribbean Aerosol Health Network, which is partnered with air quality measurements in the Caribbean Basin to look at basin-wide synchronous impacts of dust. We're trying to expand our measurement capabilities to examine transported smoke from Africa, links between dust and health impacts, as well as the transport of microplastics to the site. This is a new topic that we're quite interested in. And our most pressing needs are partnerships and collaborations to facilitate these new measurement capabilities and stable funding to continue our measurement record. So thank you for your time.